Okay, good morning to all of you. In this class, we are going to discuss about chi-square distribution. Okay, and in our last class, we have been discussed in detail about beta distribution. In detail, we have been discussed about first kind and second kind beta distribution. And in this class, we are going to discuss chi-square distribution. Okay, here you can see it is written as chi, that is a chi square, but actually it will be pronounced as ky, chi square distribution. Okay, so let's start. A continuous random variable x is said to follow a chi-square distribution with parameter n which is greater than that of the 0 if its probability density function or your PDF is given by fx equal to 1 by 2 to the power n by 2 into gamma n by 2 into e to the power minus x by 2 into x to the power n by 2 minus 1, where x varies from 0 to infinity. Otherwise PDF will be 0. For other values of x it will be 0. Now we have to prove the PDF. So if it is our PDF, then in the limit 0 to infinity, if I will integrate that this PDF, then it will give the value will be 100% or 1. So in general, minus infinity to infinity, any PDF, that is your fx, any PDF dx has to give the value 1. So here in this case, the limit will be how much? 0 to infinity, because x varies in between 0 to infinity only, and in other ranges x value, sorry, fx is 0. So only for that we have been considered this range only, that is your 0 to infinity integration limit 0 to infinity 1 by 2 to the power n, that is your PDF. We are going to consider the PDF. This is PDF into dx. Same thing, this one I have been written over here, 1 by 2 to the power n by 2 into gamma n by 2 into e to the power minus x by 2 into x to the power n by 2 minus 1 into dx, right? So this is constant taken outside. Here you can see that this will be e to the power x by 2 into x to the power n by 2 minus 1 dx. Now we have to consider x by 2 equal to t. That implies x equal to 2t, dx equal to 2 dt. Now we have to put here. This is constant written as such, 0 to infinity, x by 2 written as t. Here x will be written as 2t to the power n by 2 minus 1. Dx will be 2 into dt, 2 dt. Okay, so here you can see that here 2 to the power n by 2 minus 1, here 2 to the power 1. If I will add the power, then I am going to get 2 to the power n by 2, and here t to the power n by 2 minus 1 written, e to the power minus 2 also is there into dt. So here 2 to the power n, 2 to the power n got cancelled, and e to the power minus t into t to the power n by 2 minus 1 dt integration 0 to infinity will be how much? Gamma n by 2. Because just to recall that we know in general 0 to infinity e to the power minus t into t to the power n minus 1 dt is nothing but your gamma n. So here in this integral, instead of n we have n by 2. So obviously it will be gamma n by 2. So gamma n by 2 got cancelled, and we found one, which is proved that this PDF is belongs to your chi-square distribution. Okay, or whatever we taken the distribution probability density function has been accepted or truth. Now we are going to go for the moment generating function. In general, the moment generating function mxt is equal to expectation of e to the power tx is equal to minus infinity to plus infinity e to the power tx into fx dx. Here f is your PDF. Now we have to put the value of PDF here. this one is our PDF, chi-square PDF, chi-square distribution PDF. So here e to the power tx, and I have been written e to the power dx into, this is your PDF of chi-square into dx, and here the limit we have to consider 0 to infinity, because PDF exists in between 0 to infinity, otherwise 0, and this is constant taken outside. Now 0 to infinity is the integration limit. Here you can see that e to the power minus x by 2, e to the power tx, when the power is going to be added, we can get 2tx minus x by 2 into x to the power n by 2 minus 1 into dx. Now here what I done, that here this term as such I written, no changes. Here you can see that I taken minus 1 and x common from these two terms. What I am going to get, I will get 1 minus 2t, 1 minus 2t by 2 is there, and taken minus outside, x also outside. Okay, so x to the power n by 2 minus 1 into dx. Now we have to consider this one, this whole things is equal to z, right? So 1 minus 2t by 2 dx will be equal to dz, and x will be equal to z by this much, 1 minus 2t by 2, and dx will be dz by this much, right? Dz by this much. Okay, so now here this is the constant written as such, 0 to infinity, 0 to infinity. Here this one will be the how much, z, e to the power minus z, and here x will be nothing but your z by this much. So z by this much to the power n by 2 minus 1, to the power n by 2 minus 1, dx is nothing but dz by this much, dz by this much. Okay, very simple. So this is the constant written as such, 0 to infinity, e to the power minus z. Carefully you have to watch. Here you can see in your denominator we have 1 minus 2t by 2 to the power n by 2 minus 1, right? Here also 1 minus 2t by 2 is there. So if I will add the power, then I am going to get minus 1, here plus 1 got cancel. We are going to get only 1 minus 2t by 2 to the power n by 2. Okay, so here z to the power n by 2 minus 1 will be here, z whole to the power n by 2 minus 1 was there, so here z to the power n by 2 minus 1, dz, right? Okay, now this constant written as such, here you just say to me that 0 to infinity e to the power minus z, z to the power n by 2 minus 1 into dz will be how much. Here we just discussed that e to the power minus t, t to the power n minus 1 dt is nothing but gamma n. So here instead of t, z is there, instead of n, n by 2 is there. So e to the power minus z, z to the power n minus n by 2 minus 1 dz, 0 to infinity, that means gamma n by 2, right? And this term as such it has been written. Okay, here you can see that 1 by 2 to the power n by 2 gamma n by 2 written as such. Here you can see that 1 by 2t by 2 to the power n by 2 is there. So if this 2 will be moved to the numerator, so obviously it will 2 to the power n by 2 into gamma n by 2 is already there, gamma n by 2 whole divided by 1 minus 2t, 1 minus 2t to the power n by 2. So 2 to the power n by 2, 2 to the power n by 2 got cancelled, gamma n by 2, gamma n by 2 got cancelled, and we found mxt equal to 1 minus 2t to the power minus n by 2. Here 2t value has to be less than 1. Okay, so now we have to use either Taylor series or binomial negative binomial expansion to write these things in the expansion format. Okay, so either you have to consider the binomial expansion the mxt can be written as, or consider the Taylor series about origin. See here you have to write using binomial expansion or considering Taylor series about the origin. This line you have to write here. Okay, the mxt can be written as here, this one which is nothing but this 2t is less than 1 will be written as this one. This is the expansion or Taylor series expansion of this one, of this function 1 minus 2t to the power n by 2, where 2t is less than 1. How it is? Here you can see that I drawn for you the Taylor series of this function. In detail I have been done. So about Taylor series, if you want to watch, I given the link in the description. You can watch about the Taylor series, proof of the Taylor series. Here I am going to start from the what result of the Taylor series. So according to Taylor series, by using Cauchy's integral for derivatives, we found that if fz is a function is there, so its expansion will be n equal to 0 to infinity f n z0 by n factorial into z minus z0 to the power n, or we can write an instead of fn z0 means nth time derivative of fz, then we have to put z equal to z0. This one can be written as an z minus z0 to the power n. How we got this expression? By using Taylor series, considering Cauchy's integral derivative. You can watch that content. I given the link in this description. Okay, so here if we have the z0 is the point is at origin, and function z is belongs to function t. Here we have the function mx, or the function is the function of t, mxt, that means function of t. So here instead of z we have write f of t 0 to infinity. Here fn instead of z0 we have to put 0, because we are considering about the origin, right? Because we are trying to find out the moment generating function about the origin. So only for that we have to consider z0 equal to 0. So what will be the this one, the summation over n equal to 0 to infinity fn by n factorial 0, here t to the power n, because z0 equal to 0, so z to the power n written as t to the power n, or we can write an t to the power n. Okay, 0 to infinity an t to the power n, also we can write this one, right? Now you just expand this one, what we are going to find out. See, if n means nth derivative, so if we have to put n equal to 0, then it will be f0 by 0 factorial 0 t to the power 0 plus f dash by 2 factorial. If we have to consider first derivative, then we have to put value of t is 0. Okay, f dash 0 by 1 factorial into t to the power 1, put n equal to 2, so it will be second time derivative or double time derivative of ft. Then we have to put t equal to 0 by 2 factorial t to the power 2, then this term will be f triple dash 0 by 3 factorial into tq, and so on, right? Now we have to consider the so-called ft. The function t is nothing but 1 minus 2t to the power minus n by 2. So here first f dash so first we have to consider f0 by 0 factorial t to the power 0 will be how much? That means this term will be always 1. See, um, f of 0 means zeroth derivative will be this much. If we have to put t equal to 0 will be 1, 1 to the in minus n by 2 will be 1, again at t equal to 0 also 1, t to the 0 also 1. So this term will be 1. Okay, now we have to consider this one. First we have to consider f dash 0 will be how much. So f dash t, that means this one is going to be differentiate with respect to t. How much we can get? Minus n by 2, 1 minus 2t into minus n by 2 minus 1, again differentiation of this one with respect to t, how much? Minus 2. Okay, here you can see that. Now then we have to put t equal to 0, then we have to put t equal to 0. So this will be 1, so here minus minus, so n by 2 into 2, right? So we found this much value is how much, that is your uh, this much f dash 0, f dash 0 value we found this much. Okay, then we have to consider f double dash 0, okay. So f double dash t at t equal 0 will be how much? See, this is the value of f single dash t. Now again we have to differentiate this one. How much we are going to get? Already n minus n by 2, minus 2 is there. Now we have to differentiate this one. 1 minus 2t to the power this one with respect to t. How much I am going to get? Minus n by 2 minus 1, 1 minus 2t, 1 minus 2t to the power minus n by 2 minus 1, again minus 1, minus 2. Okay, and differentiation of 1 minus 2t with respect to t, that will be minus 2, right? So how much we can get? You can see, then we have to put t is equal to 0. T equal to 0 means this term will be 1. So here you can see that minus, here 1 minus, here 1 minus, 3 minus, and here if I will take minus, the 4 minus, so positive. At last we got the positive. So n by 2 is there. Here this will be n by 2 plus 1, here 1 2 2 square. So here we got f double dash t at t equal 0 is this much. Similarly, if you are going to do the third derivative of ft, then you have to put t equal 0, you are going to get this one, n by 2 plus 1, n by 2 plus 2 into 2 to the power 3. Likewise you can get the terms, higher order terms. Okay, now by using these 4 data, means this data, this one, and this one, I am going to trying to write the series. So here ft function was 1 minus 2t to the power n by 2 will be equal to how much? This term is nothing but 1. Then this one f dash 0 we found n by 2 into 2, and 1 factorial is there. So 1 by 1 factorial n by 2 into 2, and t is there. Okay, t is there, t, right? Then this one f double dash 2, will be this one, and we have to write down f double dash 0 by 2 factorial, that means 1 by 2 factorial. This data into t square is there. So here 2 square and t square, I can write 2t whole square. Similarly third term is this one, we have to just put over here. So 1 by 3 factorial, this much, and here t cube, 2q, we can write 2t to the power 3. So on we can get the terms. And in general one middle term can be written as, see, 1 by r factorial, see here 3 factorial, 2 to the power 3. So 1 by r factorial, 2t to the power r, right? Here you can see 3 factorial, this is n by 2 plus 2. Okay, that means 3 minus 1 will be written here, is written here. So if it will be r, so here it will be r minus 1. So n by 2 into n by 2 plus 1, n by 2 plus 2 up to n by 2 plus r minus 1. This is a one middle general term, and so on we can get. So whatever the result we got here by using the Taylor series, same written here, same written here, nothing changed. That is 1 by 1 factorial n by 2 into 2t, 2t. Here you can see 1 by 2 factorial n by 2, n by 2 plus 1, sorry, this is n by 2 plus 1, n by 2, n by 2 plus 1, 2t square, n by 2 plus 1 by 2 factorial into 2t square, right? So this will 1 by 3 factorial n by 2, this one, a third term here I have not written, directly I written the rth term, n by 2, n by 2 plus 1, so on, n by 2 plus r minus 1 by r factorial into 2t to the power r, and so on. So this is our expansion format of your moment generating function of chi-square distribution about origin. Now we are going to go for the finding the moments about the origin. Very simple, finding the moment, then we are going to go for the mean and variance. So we know that rth moment is nothing but r time derivative with respect to t of your moment generating function, then we are going to put t equal to 0, that is nothing but rth moment. Now first moment, which is nothing but 1 dash, will be how much? First time derivative or single derivative of moment generating function with respect to t, then we have to put t equal to 0. So here directly you just consider this one. Okay, in exam you can write the moment generating function of chi-square is this much, like that, but here it is already written, so I not written once again. I am going to consider the first derivative of this one. You can see that if we are going to consider the first derivative of this one, this series with respect to t, here 1 is constant, will be 0. Here this term will be n by 2 into 2, and with respect to t it will be 1. This term you can found n by 2, n by 2 plus 1 by 2 factorial. Here this will be 2 to the power 2 means 4, and t square derivative will be 2t. Okay, 2t you can get, and here likewise this will be 2 to the power r and r into t to the power r minus 1. That means except this term, all the terms will contain t after first differentiation of mxt with respect to t, right? So here I written same thing, n by 2 into 2, that means belongs to this one, and plus all terms have t. We have to consider t equal to 0. Then if we are going to consider t equal to 0, all the terms after this term, we have the t on their numerator. Okay, so if all the terms have the t on their numerator, so whenever you are going to put t equal to 0, then all the terms is going to be 0. Now we are going to get first moment mu 1 dash equal to 2 got cancel n, that is your expectation value also, or mean, right? Now we are going to go for the second moment, that is a mu 2 dash, that means 2 times derivative of moment generating function, then we have to put t equal to 0. Here you can see that if we are going to consider this term and 2 times derivative, obviously this will be 0. You consider this one, 2 times derivative you have to take with respect to t, what you are going to get? You are going to get the 0. You just consider this one and consider the 2 times derivative, how with respect to t, how much you are going to get? N by 2, n by 2 plus 1 by 2 factorial, this is 2 square is there, it will be 4 taken outside, t square derivative with respect to t with 2 time, you are going to get 2 only. Okay, here you can see t square first derivative will be 2t, second derivative with respect to t will be 2, and next term is nothing but your how much? 2tq, 2tq, 2tq means 2 to the power 8 taken outside, t to the power 3. If we are going to consider 2 times derivative with respect to t, then it will be 3t square. First derivative 3t square, second derivative will be 6t. Okay, so after 2 times derivative, this 2tq have also the t term. So hence all the other terms, all the higher order terms after second derivative will also have the t terms, right? So similar, say hence we have been written that second derivative at t equal to 2 times derivative of mxt at t equal to 0. That means only this term we are going to get. This will be 0, this will be 0, n by 2, n by 2 plus 1 by 2 factorial. This will be 2 to the power 2 means 4. And here t square derivative with respect to t 2 times, that means 2. And after that, whatever the term we are going to get, that all the terms have t value at the numerator. Now you have just put t equal to 0, all the terms are going to be 0, and we got that mu 2 dash will be how much? Here you can see 2 got cancel, 2 and this 2 got cancel. Here n by 2 plus 1, this is nothing but n plus 2 by 2. Okay, n plus 2 by 2, here n by 2. So 2, 2, 4 got cancelled, here 2 is got cancelled. So we are going to found n into n plus 2. So this is your second moment, that means expectation of x square. So hence variance is nothing but expectation of x square minus expectation of x square. That means mu 2 dash minus mu 1 dash whole square. Here mu 2 dash, this one mu 2 dash is nothing but 2 n into n plus 2 written here, and this one is nothing but only n. Square means n square. So we found 2n. 2n is the variance. In this case, for your chi-square distribution, about the mean, about the origin, we found first moment and second moment. With the help of the first and second moment, we found the variance is this one. Okay. Here one thing I am going to suggest to you, that whatever the derivation we have been done here by using Taylor series, you can write somewhere in the note. In future purposes, whenever you are going to be follow your note, you can understand easily that how you got this one. Or if you very well known about Taylor series, then no need to write, but I suggest you just somewhere you write these things with a paper and paste over here. Okay, paste. Okay. So how you are going to be paste? Suppose here you have been written. So this is the extra things whatever we have been discussed by using Taylor series. You written here. Okay, and paste like this. Put the gum and like this you have to put here this much. Then this page easily. Otherwise you paste like this. Put gum this side only somewhat, and paste like this. Okay, you can follow this page and this page also in your future, right? Here I want to say to you that whatever the moments we found by using moment generating function, these moments also can be evaluated either way. That means by considering in this way, that expectation of x is nothing but mu 1 dash 0 to infinity x into PDF of chi-square distribution into dx, right? This is constant taken outside, e to the x minus x by 2, e to the x by 2, and x here x to the power n by 2 minus 1, so x to the power n by 2 dx. Okay, so here 1 by 2 to the power n into gamma n by 2 is there, 0 to infinity, this much I have been written over here. And you just remember in our previous classes, I told to you that if we have this type of integral, that is your x to the power n e to the power minus a x to the power m dx, then this integral value will be 1 by m into 1 by a to the power n plus 1 by m into gamma n plus 1 by m. And this formula, about this formula I have one separate video and a short video itself. You can follow those videos, and also this integration several times we have been discussed. You just go back 2 and 3 videos, you can get it. Okay, and this is very famous formula, you can say, about gamma function, and I suggest that you have to always remember this uh, integration. Many times you are going to be uh, found that this integration will be required in some in different your mathematics and physics. Okay, physics derivations, physics and mathematics derivation, this integration is very useful, right? So you have to remember it. So what will the integral value here? It will be 1 by m into 1 by a to the power. So here it will be uh, a to the power n plus 1 by m gamma n plus 1 by m. Okay. So here if I am going to compare this integral and this integral, we can found easily that here n is nothing but n by 2. N is nothing but n by 2. And this, compare this one and this one. Here a is nothing but 1 by 2, and your m means x to the power m. Here x to the power 1, so m is your 1. Now we have to just use this formula that 1 by 1, 1 by m means 1 by 1 into 1 by a is nothing but your 1 by 2, 1 by 2 to the power. Here n is how much? N by 2, n by 2 plus 1 by m is your 1, gamma n by 2 plus 1, right? Now here you can see, here 2 to the power n by 2 plus 1 is there. So if this will be moved to numerator, it will be 2 to the power n by 2 plus 1. Okay, and here you can see gamma n by 2 plus 1 is nothing but n by 2 gamma n by 2. So this value is nothing but belongs to this integral. Okay, I have to just put over here. So already this one is here. So 1 by 2 to the power n by 2 into gamma n by 2 and this value. So 2 to the power n by 2, 2 to the power n by 2 got cancel, gamma n by 2, gamma n by 2 got cancel. We found 2 into n by 2 is nothing but n. Whatever we found in this way, that expectation value or mean value or fast moment is n. Likewise, you can do the integral regarding mu 2 dash or ex square, that is your 0 to infinity x square into fx dx. You just do it, you can get the answer will be this much. Okay, n into n plus 2. Okay, so I suggest that also you these things you have to practice in your rough, and no need to write down in the note. Already in our note we have been written using the moment generative function, so this way no need to write for this distribution function, but this ts you have to write down over here. Okay, it will be better that whenever you are going to revise, you are going to be recall, and at that time you will be you are not going to get any type of confusion. So this is all about your chi-square distribution and its corresponding moment generating function and moments. So go through this video carefully, write down the note, and ready for the next class. Thank you so much for watching this video. Thank you.